Okay, Bergson and the holographic theory of mind. Continuing on superdeterminism, as per Sabine Hassenfelder, which is basically going to be, as I see it, Sabine versus Bell. And Sabines' argument, and shall we say her hidden variables that float around in that argument, and I think the result, Bell wins. Sabine, as I think she likes to be called, it seems believes that quantum mechanics is in trouble. To save it, we need superdeterminism, which she notes is a bit of a crazy term since you can't be more deterministic than deterministic. But we'll see its meaning in a bit. I know I've addressed Sabine a couple times before, particularly this one where her video, you don't have free will, but don't worry, an unabated trashing of free will. And I looked at this problem again more generally with her included in this number 55. It's interesting because this video she did, You Don't Have Free Will, has 500,000 views and growing. So she has quite an impact, and which is why I like to try to modulate it a little bit. But the two I did here probably have 400 views apiece, roughly. In other words, Bergson's getting overwhelmed. I think I need you guys to like these videos a bit more. Helps the YouTube algorithm, even though I think they're kind of suppressing me for various reasons, but it would help. Unless, I would think what we're doing here is a little bit unique compared to the rest of the discussion. So anyhow, smash the like button or something like that. So her argument keys on Bell and his theorem. Bell, she holds, just wanted to prove Einstein's assessment of quantum mechanics was wrong. So for her, it's Bell versus Einstein, and Bell having rather mean motivations. Her argument supports Einstein, shows Bell is wrong, and for that matter, Schrödinger too. So let's go take a look. I'm going to outline her argument. So here it is. Point A. Bell derived inequalities that depend on statistical independence. Now, we treated Bell's inequalities as clearly as I can in 45b. But statistical independence, what is that? Pretty straight out in a simple case. Let's say I'm testing for the average lifespan of cats. It is the mean or average lifespan. And I'm just simply going to sample and compute the mean. And I take repeated samples, computing the mean. So each test, each sample, and the mean computation does not affect any other test. I can sample and sample the cat distribution. That is, a test for the mean is not affected. That is, a test for the mean, x bar, are statistically independent. I think that's the simplest case. Let's say we're testing or comparing the average age of cats versus the average age of rats, lifespan, and compare who lives longer. Again, the test, the sampling from the cats does not affect the test and the sampling of the distribution of rats. So the test, it might be a t-test, is statistically independent. Now, Bell was a little bit more fancy because we have to throw this into the relativistic context. So let's say we don't have to, but he did. We test for the cat lifespan average, sampling from a distribution of Paris, and we sample a distribution of the rat population from Tokyo. And we do this test 1 microsecond apart. So the tests are too close in time. The space separation between Tokyo and Paris is too far for any causal interaction. That is, for example, for the cats to tell the rats about the test. So maybe the rats would respond and remove all older rat people. Something like that. Some form of interaction that could take place. In the relativistic light cone framework. From Paris, for example, we have the two arrows showing the speed of light causal transmission from that point in Paris. And within the arrows is the light cone, or the realm of possible influence. And outside those arrows, well, that's outside the realm of any possible causal influence. And so when we stick Tokyo event 1 microsecond later, well, that event is outside of any possible influence from Paris, and outside the realm of possible light cone influence. So the Paris test cannot have a local, at a speed of light or less, effect on the Tokyo test. Again, statistical independence. So if the inequalities are violated, part B, any hidden variables operated in QM, and for example, a hidden variable might be the cats telling the rats, cannot be local. Again, local, that is within the speed of light framework. Point C, quantum mechanics experiments show the inequalities are violated. So the big point for Sabine, therefore, statistical independence must not be operative. Or more precisely, as she says it, it follows that any local hidden variable theory that fits our observations has to violate statistical independence. Any local hidden variable theory, like cats telling the rats. This means that quantum mechanics results depend on what you measure. That is, the particles know what we are going to measure. That is, the test for one particle is affected by the test for the other. That is, there's no statistical independence. So the test for the rats knows about the test for the cats and is affected by that. But what does this knowing mean to Sabine or Sabina? Well, we'll see. So focus on point D, the key point for this argument structure. Notice how she puts it. It follows that any local hidden variable theory, etc., etc. So the impression is given throughout Sabina's talk that this is indeed the only logical conclusion. The force of it follows. But it was certainly not so to Bell. As we saw in 45b, here's a quote. It may well be that a relativistic version of quantum theory, while Lorentz invariant and local at the observational level, may be necessarily non-local and with a preferred frame or ether at the fundamental level. Another quote, I would say that the cheapest resolution is something like going back to relativity as it was before Einstein, when people like Lorentz and Poincaré thought there was an ether, a preferred frame of reference. So we kind of see that he's going quite a different direction. As Norson summed it up in that discussion we went through on Bell's theorem, which I note again, Adam Becker thought is the only true explication of Bell's theorem. He says, Norson says, why did Bell take so seriously these sorts of ideas, that is about the ether, when everybody else today regards as completely outmoded, which everybody else today regards as completely outmoded and wrong, because he thinks his theorem and the associated experimental evidence proves that non-locality is a fact of nature, rather than merely a defect of a type of theory we shouldn't believe in. We must, that is, simply conclude that locality, that the prohibition on faster than light causation, which seems somehow to be implied by relativity theory, is false. Relativistic local causality is wrong. It is in conflict with experimental data. Faster than light causal influences really exist in nature. In other words, this would have been Bell's therefore / point D, or it follows that. Not the focus on statistical independence. Now, Sabina admits this, but always in a veiled way, roundabout. To quote, Bell didn't like the conclusion that followed from his mathematics. Well, which conclusion? Like so many before him, he wanted to prove Einstein wrong. Einstein thought QM incomplete because it requires spooky action at a distance. But Bell wanted to convince physicists to accept spooky action at a distance. Yes, but this obscures Bell's reasons entirely. He was focused on the measurement problem, just like Sabine. He had run across a very solid theory that indeed used hidden variables to solve the measurement problem. What von Neumann had proven, that is, using hidden variables, could not be done. To quote Bell, but in 1952 I saw the impossible done. It was in papers by David Bohm. Bohm showed explicitly how parameters could indeed be introduced into non-relativistic wave mechanics, with the help of which the indeterministic description could be transformed into a deterministic one. More importantly, in my opinion, the subjectivity of the orthodox version, maybe Copenhagen, we need that observer, the necessary reference to the observer could be eliminated. So this would cause him to re-examine the nature and subject of hidden variables in von Neumann, and the rest is history, Bell's theorem. So Sabine's portrayal of Bell's motivations is not compute. It seems a bit off. It's quite a bit off. It's almost purposely obscuring. It's not that Bell failed to see Sabine as no statistical independence, her point D, option. She quotes him, "There is a way to escape this inference of superluminal speeds and spooky action at a distance, but it involves absolute determinism in the universe, the complete absence of free will. Suppose the world is superdeterministic, with not just inanimate nature running on behind-the-scenes clockwork, but with our behavior, including our belief that we are free to choose to do one experiment rather than another, absolutely predetermined, including the decision, quote-unquote, by the experimenter to carry out one set of measurements rather than another. The difficulty disappears." So what he's describing is Laplace, resolute Laplace, what we'll call a strong Laplace. To expand a little quote there underneath this picture, the universe is pre-programmed, set on its path by its starting conditions, playing itself out. No room for variation or, quote, free choice, unquote. Life's not even a road, it's a railroad track. Absolute determinism. This is what he was describing, just not using the term. So she goes on, Bell called a violation of statistical independence superdeterminism and claimed that would require giving up free will. He argued there are only two options, either accept spooky action and keep free will, which would mean Bell was right, or reject spooky action but give up free will, which would mean that Einstein was right. So, no. Look at that characterization of Bell. Call it a violation of statistical independence superdeterminism. No. In reality, Bell said it would require superdeterminism to account for the violation of statistical independence. Different thing. He was emphasizing, say, as I kind of mentioned, a strong Laplace, that is, like strong AI, the complete, non-waffling, clear vision, resolute stripping of the universe, of consciousness, the psychical, thus free will, from the universe. An absolute, total, complete mechanism. So this last paragraph just seems a complete red herring. Take the last sentence, or reject spooky action but give up free will, which would mean Einstein was right. But yes, Einstein wanted determinism at quantum mechanics level. God does not play dice, yes. But I don't ever recall him, tell me if I'm wrong, arguing against free will. This entire paragraph seems twisting the issue into an issue of free will. And, she says, Bell's argument just doesn't work. Spooky action at a distance doesn't make any difference for free will because the indeterministic processes in QM are not influenced by anything. So they're not influenced by your free will, whatever that might be. So, again, you're a head scratcher. Who said free will is influencing the results? Again, only in Sabines' completely Laplacian mindset, where there's only matter, where all consciousness, save as a useless epiphenomenon, has been stripped, does this statement make any sense? I think. I've contemplated this statement for a while. I'm still not sure where she got it. Only in this framework would you think spooky action at a distance has something to do with free will. So how does Sabines' superdeterminism work? What does she mean by, quote, the particles know what we are going to measure, unquote? What to her are local hidden variables? Well, her focus is on the double slit experiment. We're firing single photons one at a time through the double slits, and lo and behold, they make an interference pattern like they're in fact a wave. In other words, instead of hitting just two spots on the other side on that screen, they make a wave interference pattern. She says, if you measure what slit the particles go through, the interference pattern vanishes. So if you measure y, psi, the wave equation, even for a single particle, describes probabilities for measurement outcomes. The wave function, which will first tell you that the particles go right or left with 50% probability each. But once you measure the particle, you know 100% where it is. So when you measure at which slit the particle is, you have to update the wave function. And after that, there is nothing coming from the other slit to interfere with. You've destroyed the interference pattern by finding out what the wave did. This update of the wave function is also called the collapse, or the reduction of the wave function. She says the collapse of the wave function doesn't make sense as a physical process because it happens instantaneously. That violates the speed of light limit. Keep that quote in mind. Somehow, the part of the wave function at the one slit needs to know that the measurement happened at the other slit. That's Einstein's spooky action at a distance. Physicists commonly react to this spooky reaction by denying that the wave function collapse is a physical process. Instead, they argue that it's just an update of information, which is really clear, right? But information about what? In QM, there isn't any further information beyond the wave function. No information beyond the wave function, which implies that the Schrödinger equation is perfectly sufficient to explain the universe, which Schrödinger said is BS. See number 60 on that. So, comment there. In other words, all of this floats around all these other problems. Like, what really is the wave equation actually worth in total? Which Schrödinger himself had great problems with. Not to mention, as we'll see, the whole problem of the Born rule applied to the Schrödinger equation. So she goes on. Interpreting the collapse as an information update really only makes sense in a hidden variable theory. In that case, the measurement tells you more about the possible values of the hidden variables. So we are to think about the hidden variables as labels for the possible paths a particle could take. Labels is kind of misleading, but we'll go through it. Say, here's our picture. Particles 1, 2, and 3 go through the left, and then 4, 5, and 6 go to the right, and 7 through 12 go through both. So notice they're making an interference pattern. The particle has one of these hidden variables, a label, but we don't know which. He says if we measure the particle at the left slit, that simply tells us the particle is in the 1 to 3 batch. If in the right, then in the 4 to 6 batch. If we measure it on the screen, so looking at on the green area there, it was in a 7 to 12 batch. No mystery, no instantaneous collapse, no non-locality, but it means that the particle's path will depend on what measurement will take place. Okay, that's what she means. Because the particles, back to this, must have known already when they got on their way, whether to pick one of the two slits or go through both. This is what observations tell us, And that's what superdeterminism is. What the quantum particle does depends on what measurement will take place. Remember that quote. But for all that has been said, I can see this is nothing more than this. That is, we're doing nothing more than putting labels, quote unquote, on the paths in a Laplacian universe. Now, Sabine reviews this relation. Here we go on the symbols. Lambda is the hidden variable. Rho is the probability distribution, A and B, the detector settings at the time of measurement. And so we have the probability for lambda, the hidden variable, given particular settings. And the not equal sign says that, well, given the detector settings, we're not getting a normal distribution of lambda. Something's changed. So statistical independence violated implies the probability for a quantum particle to do a particular thing depends on detector settings at the time of measurement. And contrary to what Bell and Schrödinger argued, this relation does not restrict the freedom of the experimentalist. Why would it? The experimentalist can measure whatever they like. It's just that what the particle does depends on what they measure. But the experimentalist is embedded in this deterministic, mechanistic machine, the Laplacian universe. Measuring whatever they like is an absurdity, a joke on them. This is quite a bit of a sleight of hand with Sabine now. Sabine now takes things to the macro level. Vaccine effectiveness testing. Randomly assign people into two groups. Group 1 gets the vaccine, Group 2 a placebo. The hidden variable is the group assignment. So, picture there. And the measurement, the test for type of illness, if someone falls ill. So, apparently then one can ultimately determine what group, depending on the illness, that the person came from. But she says, if you think that what happens to people depends on what measurement you do on them, then you can't draw conclusions about the sufficiency of the vaccine. All righty, she says. But people aren't quantum particles, and believing that superdeterminism plays a role for vaccine trials is like believing Schrödinger's cat is really dead and alive. So we kind of ask, why? What's the difference between this macro level, and this micro level? Vaccine versus quantum collapse. Why is the macro different from the micro? Doesn't the micro underlie the macro? And then there's this interesting question, like believing Schrödinger's cat is really dead and alive. But both Einstein and Schrödinger saw that this is the logical implication of psi, of the time evolution of the equation. So how has this been changed? That this is no longer a superposition within the evolution of the wave equation. Well, we're about to see. We've actually kind of seen it, but we'll wait. Because lurking beneath this is the Laplacian machine. This is basically Dennett, who was a total Laplacian, who spent pages attempting to convince us that if we move up to the macro level of experience, the role of golf ball, putting, and making decisions in the stock market, that things are so complicated that we are effectively free. So a giant exercise in creative cognitive dissonance, because he was basically saying, don't look here, don't look at the mechanistic unfolding, unrolling of the Laplacian machine that you're really all inescapably apart from. Just think about things in terms of making stock market decisions or putting golf balls. Sabine reinforces this, its micro-only stance. That is, somehow the macro level, the classical, is not affected by the total determinism of the micro level, the quantum. To quote, the correlation between the detector setting and the behavior of the quantum particle, which is the hallmark of superdeterminism, only occurs when quantum mechanics would predict a non-local collapse of the wave function. Remember, that's what we need superdeterminism for, that there is no spooky action at a distance. But once you have measured the quantum state, that's the end of those violations of statistical independence. But the statement, the correlation, the hallmark, this is not the hallmark of Bell's superdeterminism. Rather, I would say that of Sabine's selective superdeterminism. Look at Bell's quote again. Suppose the world is superdeterministic, which is with not just inanimate nature running on behind the scenes clockwork, but with our behavior, including our belief that we are free to choose to do one experiment rather than another, absolutely predetermined, including the decision by the experimenter to carry out one set of measurements rather than another, from Bell. That is, it's precisely this, the purely, totally mechanistic Laplacian world. There's nothing free outside of that. Now we look at this statement, which only occurs when QM would predict a non-local collapse. So again, what's she talking about here? And again, our two tests. Age of cats in Paris, age of rats in Tokyo. They were statistically independent because they were outside, the Tokyo test was outside the light cone from the Paris test. But suppose we had tested rats in Rouen, real close to Paris, we'll say. And therefore the test was within the light cone of the Paris test. In other words, it could be influenced by less than light speed transmission. So we have a local collapse, and that's what she's talking about. Now, she's already acknowledged, however, that all collapses are instantaneous and don't make sense as a physical process. So already, it's just not a matter of local versus non-local collapse. They're not a physical or not a physically understandable process because they're pure mathematics. They happen in instantaneous at a zero time. It's simply a mathematical collapse. This is what Schrödinger absolutely disputed as having any reality whatsoever, as we saw in number 60 of this 52 article. And she provides nothing to remedy this, unless, of course, collapse disappears, which is in reality what has to happen. She says here, remember this we need superdeterminism for. No spooky action at a distance. That's what we need superdeterminism for. But here's the problem. Once you've set everything on this Laplacian path, all collapses, local, non-local, are determined by the same mechanistic unrolling. The Born rule probabilities might be correct, quote unquote, but are a complete illusion, another cosmic joke. There's no probability really going on whatsoever. It's one giant mechanistic unrolling, one giant cosmic scale, well, quote, spooky action, unquote. So the Born rule, taking the square of psi, which she says she holds to, well, if there's no collapse, what role? What status? It has none. Without the collapse in the Copenhagen framework happening over and over and over again, psi just evolves forever. In fact, into dead and alive cats. And so this is what we see she meant by you're nuts if you believe that there can be dead and alive cats, because in reality, there is no probabilistic and evolving multiple superposed possibilities in the wave equation, because it's all deterministic. It's just that now determined and rolling. So she can't be selective, though she is. And finally, again, looking here partially at the core is the unresolved problem of the transition from the quantum to the classical, from particles to bowling balls, which Sabine seems to have resolved by saying, and it's gone. Yeah, I like that meme. Conclusion. For Bell, his theorem leads us back to the ether, to question the framework of the limiting speed of light, even to Bohm, possibilities virtually non-existent to Sabine. This whole problem is entwined in physics' absolute wreck and special relativity. The illicit foundations of general relativity, as Bergson pointed out, their premature and questionable rejection of the ether. In other words, it's a mess. And note, Sabine thinks her solution provides the basis for reconciling quantum gravity with general relativity. Well, if you want to reconcile general relativity, have at it. I've complained, I don't want to be discussing physics, but I've kind of been forced here by the mess they made of time, as I discovered as I started to look in special relativity. Thus, of any possibility for a decent theory of consciousness. Yet physicists pour into the discussion of consciousness, free will, the hard problem, basically like we're seeing here, with no clue how intricately tied this problem is, consciousness, the hard problem, to perception, memory, cognition, action, nor with any reflection on their own base metaphysic of space and time. Again, Bergson, it's the very essence of mechanism, Laplace, to consider as metaphorical every expression which attributes to time an effective action. It's the real core of their problem. In any case, I think free will is safe from Sabine. So, next we'll see. Till then, signing off.